So Formula One, another topic that is close to my heart. We're looking at the normal distribution being used as an approximation to the binomial distribution. So what we're talking about here is using the normal distribution to approximate the binomial distribution. So we're looking at, let's say x is the letter we give to the binomial distribution. Then when we use a normal approximator, we'll call that y. The mean of the normal is n times p, and the variance is n times p times 1 minus p. So the conditions that need to be satisfied are that n must be large and p must be close to 0.5. What do we mean by those two things? Well, large, typically the rule of thumb is above 30, and close to 0.5, well, is 0.4 close to 0.5? Is 0.3 close to 0.5? What we say is that the closer the probability is to 0.5, the better the approximation, and the larger the n is, the better the approximation. So for part B, we're looking to compare the normal distribution and the binomial distribution. So the probability of, well, we're saying success here. Success is a time above 135 seconds. And probably if you're in the Formula One team, that might not be success. But we're saying that the probability of success is 0.4. And we're talking about an n, a random sample of 75 lap times. So we're looking at the binomial distribution of 75, 0.4, and we're trying to find the probability that exactly 25 of those laps are classified as success, i.e. being above the 135 seconds. So using a calculator gives us this probability, and I've written it down to 6 decimal places because we're looking at a percentage error. So we're looking at the difference between two fairly small numbers, so I want to make sure I get a reasonable degree of accuracy in my calculations later on. So that's the actual probability. We need to find out what the normal distribution would approximate this probability to. So to find the values in the normal distribution, we need to find what np and np 1 minus p are equal to. np is 30 and n times p times 1 minus p is 18. So that means that the approximating distribution y is normal with mean 30 and variance 18. So using the normal distribution as an approximator, the approximate value of x, a probability of x being equal to 25, is the probability that y is between 24.5 and 25.5. This is because the normal distribution is a continuous distribution, but the binomial distribution is only a discrete distribution, so we need to use the continuity correction. And using a calculator with the lower figure of 24.5, the upper of 25.5, mean of 30, and standard deviation of the square root of 18, we get this number, which you can see is fairly close to the actual figure. We're now in a position to work out the percentage error, and that is the estimate minus the actual divided by the actual times 100, and that is a figure of minus 1.8%. Okay, there we are.